Okay, good evening, good morning, good afternoon, wherever you are in the world. Thank you for joining us on another one of our LIDNUG monthly presentations. Got the usual run-of-the-mill stuff to do. We've got Omar Al Zabir, author and co-founder of PageFlakes, with us tonight, who's going to explain to us how to scale ASP.NET websites from thousands to millions. One of these I've been looking forward to. Just before we do that, however, thanks once again to our sponsors, Orcsweb, without who we wouldn't have LIDNUG.org, Telerik, without there would be nothing on LIDNUG.org, and Safari Books Online. Well, we've got some neat swag to give away from them for all you guys out there. As usual, here's our links. You can come and join the LinkedIn group at group ID 43315. You can visit us at lidnug.org. We also have our various calendar feeds there, which you can import into your favorite readers, favorite RSS programs. All our events are always on the LIDNUG events page at Eventbrite. After a long absence, we finally started making use of YouTube and got that up and running, so all of our presentations are going on there now. Twitter, Facebook, you can reach us by email, info@lidnug.org. As is usual, the entire team, without which we couldn't do any of what we do. Wrong slide. And that's it. Thank you very much. I'll now hand over to Omar. Omar, are you ready?
Yep, I'm ready. Thank you.
Take it away, my friend.
Sure, let me switch to my presentation. Okay, hopefully it's on. So hi everyone, I am Omar Al Zabir. Just to correct the introduction a bit, I was the co-founder of PageFlakes. Now I work for BT and the chief architect at SaaS platform BT. So today I will share some interesting experiences I had scaling ASP.NET websites from 1,000 users to millions of users. And my previous startup was a big hit. We eventually got acquired and we were lucky to serve millions of users. So there were quite some lessons learned designing, building, deploying, and maintaining that on production. And also there are some dark arts you really have to master before you go live with any ASP.NET website, and today I will address some of those. And if you are going to be hit by millions of page views per day, there are some really hardcore tuning you have to do. So I will share some tips today on how to make best use of your hardware power, then how to tune ASP.NET config to get the most out of it, and some production disasters and how to get out of such situation with your dignity preserved. So moving to the next slide. So before we talk about anything to do with scalability, first of all, you need to know how do you blow up a website, because unless you don't know, you can never test and make sure that your website is really scalable. So here is an easy way to blow up almost any website. So get a couple of quad-core desktop with really fast internet connection. As a BT employee, I will try to sell you a super fast fiber broadband from BT, but anyway, get some really super fast fiber broadband. And this is what you need to run. All it does is that it launches hundreds of parallel hits to a certain URL. So try to hit a URL that is an expensive page and takes quite some time to render. And keep running it, and hopefully the site will be gone within a couple of minutes. And the reason the website will die is that it's just way too many requests you're throwing at the web server. So what's happening is that web server is starting threads to execute your request. But at the rate that it can execute the request and close the thread, it's getting more requests queued in. So more and more requests are getting piled up on the web server, and eventually the web server runs out of threads. So when there are no threads available, there's nothing happening, so users are waiting, your website is essentially down. So if you analyze that, what this is called, this is actually called a application level DDoS attack. So we have heard about denial of service attacks. Most of the time hackers do network level denial of service attack. So what they do is that they send malformed TCP fragments, some ridiculously large payloads or some really malformed instructions, and that kind of, they know that how to get around the driver code and how you can really throw some specific payload to make your network drivers go crazy and then eventually stop serving any traffic. So that's the network level denial of service attack. What here I have just showed you is the application level denial of service attack. So what it does is that it hits some very expensive pages that are kind of CPU intensive and have a lot of content, and it takes a while for your web server to execute such page. And when you hit such page very frequently within a very short duration, all the threads on your servers are kind of used up. They're executing the requests. So when the new requests are coming in, they are getting queued and queued and queued, and the website is essentially stops responding. It's not just that web page, that certain expensive web page is down, your entire website is down. So nothing is happening on your website. And there's nothing there, no software, no network level firewall that you can use to block this, because these are legitimate requests. Someone is hitting some legitimate page a bit frequently, more than as usual, but that's a legitimate request that can be coming from anyone. So for this kind of denial of service attack, you really have to take care of handling those situations, writing some custom code. So here's the one solution that you can adopt. It's not the only solution. There are many ways to prevent this. So this is the thing that I usually use. I used it in my previous startup, and I also use it in the applications that we build today to prevent this kind of sudden flood of traffic. So the idea is that you maintain a counter of hits from a given IP. So certain client, how many requests you are receiving from a certain IP, you're keeping a counter. So you can start counting how many requests you're seeing from, let's say one IP is 128.0.0.1. And as soon as you see any hit coming in from that IP, you increase the counter. So you count how many requests you have received within last 10 minutes. If it exceeds a certain threshold, let's say it's more than 500, you stop serving that IP. So you just call response.end. So the way I usually build is I build a HTTP module and I hook the onInit event. And in that I keep recording what's the IP of the client, the request. From the request object, you can look at the user host address property, and that will tell you the client IP address. Sometimes it's a proxy IP address. And then you keep a counter and you store them in a cache. I'm using regular ASP.NET cache, where the key is the IP and value is the number of hits I have received. And you set an expiration time on that cache, that after 10 minutes that key will be gone, so that the counter restarts from 0. And if a threshold has exceeded after a certain within a certain duration, then you just call response.end and the request terminates immediately. So the idea is to capture this as early as possible. So that's the onInit event, and before the ASP.NET pipeline gets a chance to execute, and that will consume some CPU. So you capture it on onInit and then immediately call response.end to end the request with least amount of CPU consumption. So you can go to this URL, the tinyurl.com/OmarDOS. It's a case-sensitive URL. The whole solution is there. It's just a HTTP module that you can put on your website, and you're more or less protected. So that's how you prevent DOS attack. And another thing that you can do is that you can beef up the default configurations that are there in the ASP.NET process model, so that your servers can handle more requests, more concurrent requests. So the default values that ASP.NET comes up with are really poor. So I remember ASP.NET 2.0 came like around 2012 or 13, I believe. So it's about 10 years back. And back then, I don't think there was a quad-core server. So dual-core servers were there, and they were very expensive. So I think the most common servers were regular Pentium servers. So Microsoft decided a very moderate default configuration, and that's 20 threads per core. So if you have a dual-core server, the maximum concurrent request it will serve is 40 requests. So 20 per core, that means in a dual-core server, that's 40 requests. So that means that if 40 requests are executing, any other request that comes in from anyone, they are going to be queued. And until some thread is free, some request has completed, those requests will not be executed. So it's a bit, I think it's a bit low setting for nowadays, the kind of traffic we get and the kind of hardware power we have. So you could easily increase them to some higher values. So I usually set 100 in max worker threads, and max IO threads you would want to increase them if you're making a lot of IO calls. So IO calls can be external WCF call or external HTTP post, so you can increase that limit as well. And if you're hosting only ASP.NET application or your web application on your server, you could easily increase the memory limit as well. So you should increase this value if you're not suffering from excessive CPU use. So if your web application isn't very optimized and it's causing a lot of CPU anyway, then you shouldn't increase them, because there's no point getting in more requests than you can serve. But if your web application isn't consuming that much CPU, you see that your CPU utilization is around 25% or 30% or so, then you could easily increase them if you see that you're really getting more than let's say 40 requests per second. So your logs show you that you are getting more than 40 requests per second. So I would suggest increasing this value right away. Okay, the next optimization you can do is that you can remove some default modules that comes with the .NET default setting. So what happens is that the ASP.NET has a request pipeline. It's like a factory pipeline. So every request gets into the pipeline, and all the modules that are registered in the request pipeline gets a chance to look at the request and do something. So the default modules, I have copied this from the machine config. So the default modules are output cache, session, Windows authentication. So all these modules are there. So they are sitting there in the ASP.NET pipeline, intercepting each and every request that is coming into your application. So each and every of this HTTP module is doing something. They are at least deciding, shall I do something? Do I have to do anything? They look at the configuration setting, web config, and they try to figure out, do I have to do something with this request or not? This is entirely unnecessary if you are not using any of this. So if you are not using Windows authentication, you could remove that module. There's no need for that module to be sitting there and intercepting each and every request and at least consuming some CPU. Then passport authentication, who has ever heard of anyone using passport authentication? So you could remove that. File authorization, I would really recommend never using this file authorization. So you could remove this. So there are a couple of things that I usually remove from my web application. So these are the default settings I usually put in my web config. So they remove all the unnecessary modules. So if you're using session, don't remove the first session. So I usually use ASP.NET membership and profile provider. That's why I have removed session. I don't use session. But if you're using session, don't remove that. But the rest of the things are more or less, you can get rid of them. So that removes some unnecessary modules intercepting each and every request and saving some CPU for you. So the next thing that sometimes the ASP.NET developers overlook is the gigantic cookies that ASP.NET produces. So if you're using the ASP.NET membership provider, you would get that DBAuth cookie, the YOLO one, the DBAuth. The 12 is, I have put that, so usually it's the DBAuth. So that's a gigantic cookie you will get generated if you're using ASP.NET membership provider. If you're using the anonymous provider, then you'll get another DBAnon cookie. So this is a cookie from one of my websites where I'm using ASP.NET membership, and nothing fancy, default ASP.NET membership and a regular anonymous provider, and it's generating this gigantic cookie, 517 bytes. Now you might think 570 bytes is a peanut, it's nothing. But think about this. This cookie is being sent on each and every request going to your www subdomain. So if you have www.yoursite.com, every single request browser is sending to that subdomain, this cookie is being sent. So that is being sent for CSS, JavaScript, image, AXD, ASPX, AHX, everything. Any request that goes to your web server. So on an average page, if you have 40 resources, by resource I mean CSS, JavaScript, images, anything that is there that makes a hit to your server. So you're consuming 20 kilobyte per page. So if your page is 100 kilobyte, it's 20% gone there, unnecessary data transfer. And if you have 1 million page view, that means the whole world has uploaded 20 gigabyte worth of useless data to your web server and consumed your bandwidth, precious bandwidth, for nothing. You don't need any of this cookie for your CSS, JavaScript, nothing. So the solution is very simple. What you do is that you create a new website in IS and you map that to the same folder. This is the same code folder where your www.yoursite.com is running. And name that website static.yoursite.com. So you configure the specific domain to be served by this specific new website, static.yoursite.com. So you have a www.yoursite.com, that's your regular web application. Then you have the static.yoursite.com, that's a different web application you have configured. And then what you do is that on all your CSS, JavaScript, image links, you put this prefix http://static.yoursite.com/ let's say some jQuery.js. So each and every CSS JavaScript image you have, just put this absolute prefix in front of it. So what will happen is that all your static files will download from this starting static subdomain. Now on this subdomain, ASP.NET is not generating any cookie. So ASP.NET is generating on your www.yoursite.com subdomain. It's not generating on the static. So what will happen is the browser will not get any cookie on this subdomain. Thus, it will not send any cookie on that subdomain. And in case some cookie gets generated on this static subdomain as a contingency plan, what you can do is that on your global SX end response event, you could write this code. So basically what this code does is that it looks at the request it has received and checks if this request is on that static yoursite.com. If it is, then it looks at all the cookies it has received on the request and just expires them. So that in case some cookie gets generated by something on ASP.NET, mistakenly, then at least those cookies will be removed. So this will eliminate any chance of having any cookie being transmitted. So you can do this very simple quick fix and save gigabytes of unnecessary bandwidth being consumed from your web server. Another thing you have to remember is that the upload from consumer's PC is usually 1/10 or sometimes even slower than the download bandwidth. So the upload actually takes 10 times more. So if browser is uploading 1 kilobyte, the time it takes to upload 1 kilobyte is almost always the time it takes to download 20 kilobytes or even more than that. So it's wasting unnecessary time. It makes your websites respond slower to AJAX calls. So if you click a button and you're making an AJAX call, it introduces some delay there. Or if it's downloading pages, you can see visible slow response. So it's better to transmit as little data as possible from browser to website. We usually try to optimize the other way around. We try to optimize downloading bytes from your server to client's PC. So we do a lot of optimization to reduce that. But we sometimes overlook how much byte the browser is actually uploading to the web server before it even gets anything back from web server. So that's the area that you need to sometimes focus on. But these are, of course, in a really very high traffic websites. If your website is being used by 10,000, 100,000 users, you don't probably bother about this, but it's always good to have. The next one is a really killer default configuration that most of us overlook and suffer from a bottleneck, and this is a very hard to detect bottleneck. So what has happened is that in the .NET default configuration, the default parallel TCP connection you can make for anything, whether you're doing HTTP post, a HTTP web request, or you're making a WCF call, anything that is going to open a TCP connection. The default limit is 2 per IP concurrently. So if you have 1,000 users visiting your website and your website is calling some WCF service, it will only be able to make 2 concurrent requests to it. So let me show you how bad it is. So look at this, that you have many users visiting your website and your website happens to call some WCF service. So it will only be able to make 2 calls simultaneously. So once 2 calls completed, then another 2 calls. Once that call's completed, then another 2 calls. So your bottleneck becomes this website to WCF service call. And it's not WCF service. Even if you're making a regular HTTP web request, that will also suffer from this default 2 simultaneous connection. And if you have a desktop WCF client, let's say that you have a desktop application that is making calls to WCF services, then you have done a lot of optimization. You have done parallel calls, implement a thread pool to make as many parallel calls as you can to accelerate the user actions or loading of data. But you see no improvement because it's still suffering from that system.NET default configuration. So what I do is that I always beef it up. So I always change it to 100 or so, some high IP. Some high number of connection you can set. If it's between your web servers on the server side, you could increase that even further. But if you are doing it on a client application that is deployed on a client PC and you are putting it on an app config, I would recommend putting a lower value, because in case some client goes mad and starts firing a lot of thread and hits your web server, that will work as a denial of service. So if you have a moderate value there, like 20 or 30, it will at least throttle it down. So on a desktop PC, try to put some value like 2030, but on between your web servers, on the server side configuration, you can put as high value as you feel necessary. Okay, then the next thing is about some optimization I have learned from tuning the ASP.NET Profile Provider. So I used to use the Profile Provider a lot. So you know that handy tool that you can easily add custom properties to your profile provider, and then they become available as a strongly typed property throughout your web application. So you can have a profile.fullname or profile.contact email address easily introduced. So it's a pretty handy feature, and I used to use that a lot. But that has some performance problem. So what happens is that whenever you try to read any custom property on the profile object, it will first have to load that from the database. So it calls a stored procedure, ASPNET underscore profile underscore get properties. So that stored procedure, you would assume that it will just have a simple select star from ASPNET underscore profile where user ID equals to something, that's it. But it's actually a pretty sophisticated stored procedure. So first of all, it tries to look up your application ID from your application name. Ideally, you should have one website configured on one database, so this should be unnecessary. You could easily just have a fixed application ID on it, or this profile provider could actually take the application ID as an input parameter and save one lookup. Then it has some couple of select statements in it. And the killer thing is that it tries to update the ASP.NET users table with the last activity date. So every time you are trying to read from profile, so first time in a request you are trying to read any custom property of a profile, it's trying to load the profile from database, and while loading it is going to update the last activity date on the ASP.NET users table. And we know that this table is a very high rate. If you're using a ASP.NET membership provider, this is a really high read table, and you don't want to update that so frequently. So if you look at the query plan of this stored procedure, you can see that how bad it is. So there are about 1, 2, 3, 4, 5 queries being executed. So 5 rows affected just for one read. And the 79% cost is in this last query, which is trying to do an update on the ASP.NET users table. And it's doing a clustered index update, which is a pretty expensive operation. So you should definitely tune this stored procedure if you're using the ASP.NET default provider. The way the SP is written isn't optimized or tuned to serve millions of requests. I guess Microsoft hired some summer intern to write that, maybe. But the tuning you need to do is that there's really no need to update the last activity date so frequently on each and every request. You might add some logic that if the last activity date is less than 1 hour, they don't bother updating it. If it's more than 1 hour, maybe you can update it. Or maybe you can do a day check. I mean, in case you need the last activity date, generally you wouldn't need it at an hour level or a day level, maybe sufficient for you. And the other thing you can do is that just hardcode the application ID and at least save one select star from ASP.NET applications table. And you can get the optimized stored procedure from this URL. Again, that's a case-sensitive URL. And I believe I have done some other tuning on other ASP.NET membership stored procedures there as well, so you will find those there as well. The next optimization I'd like to show you is that whenever you are scaling your website to millions of users, and the first train the database gets is on the ASP.NET table, so ASP.NET users table or ASP.NET profile table, they get a lot of hit. So almost for every user, every logged in user, those tables are being hit at least once on every page hit. So what happens is that since those tables are very high read and they are being modified more or less moderately, so you tend to have this kind of transaction deadlock on a resource exception coming out from your SQL server. Sometimes you get a query timeout if some transaction gets stuck. So this is the normal thing that happens usually on any large table on any database technology. It's not a ASP.NET membership fault, by the way. This is a common problem in any database provider that if you have a large table and it's a very high read and a moderate write, you usually tend to get this kind of long transaction deadlock and timeout problem. And the reason is that the default transaction isolation level is serializable, which is the strictest transaction isolation level out there. And you don't want that kind of serialization, transaction isolation level. You usually need that on tables that are used in banks. So you are transferring fund and you are trying to update the account balance. Only then you would need that kind of serializable isolation level, which ensures that there is no way the same record is being updated by two concurrent requests at the same time. So you get into a data atomicity problem. So what you can usually do is that if your tables are very high read, and they are quite large, like users table, where you have millions of users, so millions of records are there. You could just set this transaction isolation level read uncommitted. So what it does is that it doesn't lock the rows or the page. It's almost as simple as with no lock. So there is no locking done on the page or the record you're trying to read. So as a result, you don't get into this kind of transaction deadlock or query timeout problem, even if you are hitting that table and trying to read 1,000 times per second. So you can scale as much as you want to be. So with this kind of transaction isolation read uncommitted. So when you start getting a lot of traffic, you will start seeing this kind of errors being thrown from the ASPNET membership stored procedures. So what you can do is you can go through all the stored procedures and put this transaction level at the beginning of every single stored procedure. So I have done this on all my stored procedures and haven't seen any problem yet that the user's records are getting modified parallelly and then they are getting into inconsistent state. Usually a row that belongs to a single user, it's very unlikely that at the same moment two different requests will try to update the same record with two different values. It's very unlikely, because usually from a single user you would be getting 4 or 5 parallel requests maybe, and by the time they go through your web server to your all the layers of code you have written, it eventually through the network reaches the database engine, and then it eventually gets a chance to execute the stored procedure and hits the table. I'm pretty sure that by that time the requests have lost the concurrency level, so they are not going to hit the exact same row for the same user exactly at the same time. So you could easily do this for this kind of high read and medium modification tables. But of course, if you work for a bank, never do that. The other thing is that when you start using ASPNET membership provider and you are making a good use of the default ASPNET users table, you might want to run some simple queries on them. You might have some table where you do a find on a user. So you have a text box where somebody puts a username and you have a find button and that finds the username. A very simple requirement, a very common requirement. Or you might want to get some record based on the user's email address. So there's nothing wrong with this kind of simple query. But what happens is that if you run this kind of query and you have millions of records in this table, this is what your database server's task manager will look like. So we had this kind of problem because we had some pages that were running this query. And the problem is that these fields, the username and email, none of them are part of index. So whenever you execute this query, the SQL server has to run through the entire table. It does a table scan. And you know the table scan is the most expensive thing to do. So it kind of locks the whole table, does a complete table scan. And it's a very, very CPU intensive operation. Not just CPU intensive, it's a significant IO intensive operation as well. So if you look at the indexes that are there on this table, there is a cluster index on the ASPNET users table that has application ID and lowered username, not the username. Then on the ASPNET membership, we have the application ID and lowered email. So you cannot use the username or email, or in fact, you cannot use directly the lowered username and lowered email. You have to put the application ID in the wire clause. Otherwise, it will hit the table again. So all your queries, you have to write where application ID is the application ID of your application and lowered username or and lowered email. Only then the index will hit. So that was a lesson we learned. Some developer missed that. They used the common sense and used the email and username field and blew up our website. So now here's the interesting story. So 5 or 6 years back, I remember that all of our applications were using the old ASP.NET 2.0 and .NET 3.0, and then .NET 3.0 was released. And it was so fantastic. We got to use WCF. Finally, we could get rid of our stinky ASMX services. They were so bad, so poorly designed, so bad architecture of creating web services. So we got to use WCF. We could use the same code to be exposed as SOAP and exposed as a HTTP POX and then as a REST. It was beautiful. So we replaced all our service layer with WCF. Then we had lambda expressions. So usually we have 10 levels deep nested for, if, almost throughout our code base. And we could get rid of all those 10 level nested code where the actual code is you have to horizontally scroll on Visual Studio to see it. So we could get rid of all of those code and use lambda expressions. So sometimes a single line lambda expression, which looks like a Shakespeare para, and it actually replaces 100 lines of for, if nested condition. So our code looked beautiful. We replaced all these complex nested conditions and loops with lambda expressions. The best thing we got was the link to SQL. Finally, some ORM framework directly from .NET framework. So we no longer had to deal with SQL connection, SQL command, SQL properties, data reader, and all these things. Hundreds of lines of code you write to read simple object and write simple objects. So we replaced everything with link to SQL. So we did a complete upgrade, .NET 3.0 top to bottom, from ASP.NET middle tier, everything. And there was a major deployment over the weekend, Monday 9 a.m. traffic hit us, and our website was down. There's no response from our website. After 5 or 6 minutes, somebody saw some page, but that's it. There's nothing there. So when we logged into our web servers, it looks something like this. All our web servers, if you look at this screenshot, Task Manager, they are all actually 100% CPU. So even if it's a double core, that's 100% CPU, quad core 100% CPU. So all our web servers were looking like this. And W3 WP process was taking 100% CPU everywhere. So we were essentially dead. So the reason was, it's very interesting that the reason wasn't the WCF upgrade. The reason wasn't the lambda expression. The reason was the least expected, the link to SQL. So you would have thought that if Microsoft releases a ORM framework, it must be really tested to death and load tested severely with millions of requests. But surprisingly, it wasn't. Link to SQL wasn't really optimized for web application. So if you know the link to SQL architecture, there's a data context you create or you generate from your table, and then you also get the entities generated. And none of those entities are serializable. I mean, who designs an ORM layer where the entities are not serializable? That completely goes out of my mind. And then the worst thing is that those entities have a change tracker on them. So the data context is holding a reference to the entities. And think about the impact it has. So you have a beautiful interior application. You have a web application layer calling some business facade. Business facade is calling some data access layer. You have implemented the beautiful repository pattern, and it is calling the data context and getting the entities out of it. Now the entities are returned back from data access layer to your business facade, and business facade is returning back to your web application layer. You would imagine that the business facade is gone, is done its job. The data access layer class you instantiated, that's also gone. But actually none of them are gone. The data context that has been created at the data access layer is going to be around, and it will be live as long as you are still holding on to the entities on the web application layer because of the change tracker. The data context doesn't die. It remains in memory as long as the entities are alive and you are using them. So if you somehow store those entities on ASP.NET Cache, the data context is there, although the request has ended. So it's a really bad design. For link to SQL is definitely not suitable for interior architecture. It's not suitable for web applications. So I wouldn't recommend using it. You should be better off with entity framework, which is serializable, and you could detach the entities from the object context. But the main performance problem was actually from this kind of query. So we had this kind of simple queries, lambda expressions, link to SQL lambda expressions. So where query from some table, which is very trivial, is trying to select a single record and is doing a single query. So this kind of simple lambda expressions were causing very high CPU. And I did some search, and I found a blog from Jerry Conley who showed why this is so bad. So such a simple query actually calls a method called SQL Visitor Visit, which is at the bottom of the slide, more than 1 million times. So you can see that just to parse a simple link to SQL expression and convert it to a regular SQL command that gets executed on the SQL server, that conversion, there is some internal function called SQL Visitor Visit, and it's being called over 1 million times. And that's the main reason for this high CPU consumption. So the solution was very simple, though. The solution is that you cannot write this kind of lambda expressions throughout your code base everywhere, wherever you want them to be. You need to convert them to something called compiled queries. So it's a bit complicated topic. How do you convert a regular standard link to SQL query to a compiled query? So I recommend you visiting this link and reading the blog post. I have showed you how you can take an existing query and very easily do a refactoring and convert it to compiled queries. So once we converted to compiled queries, all our problems probably were gone. Our web server was back to around 30% CPU utilization. We were back live, but it cost a lot of time, money, and dignity, of course. We were down for almost a whole day, and that cost a lot. If you're in a startup, a whole day downtime usually means that your VCs are going to call and demand their money back. So you don't want to be in such a situation. Okay, the next thing is that the same kind of transaction deadlock problem. So we talked about this problem before, that ASP.NET membership providers, if you're scaling your website to millions of users, you're eventually going to hit this problem. And it's not a problem of ASP.NET or Link to SQL. It's a problem with your database technologies that you're using. Whether you're using SQL Server, Oracle, whatever you use, you're going to get this kind of problem if you have a very large table, millions of records, and you are doing a very high frequency read on them and moderate write at the same time. So what we have to do is that we somehow have to pass this set transaction isolation level read uncommitted on the connection. So one way to do this is that as soon as you have opened the data context, you manually open the connection and then you manually execute this command. Then this connection is now set on a isolation level of read uncommitted. So all the SQL queries that are going to be executed on this connection, they will enjoy this isolation level. And then you do your usual queries, usual link to SQL queries. I have shown a very simple thing here, but you can run whatever you want there. And then you eventually dispose the connection. So when you do this, your problem will go away, but due to a bug in link to SQL data context, you will soon see is that the connections are never closed. So although you are opening and you are doing a nice dispose and everything, but you'll see that the connections are not closed. So within 5 minutes of going live, all your connection pool will be exhausted and your website will be down again. So the solution is that you create a new data context class that inherits the generated data context. So here I have shown an example that I've hand-coded this your data context 2, which extends the your data context that is generated by Visual Studio. And I override the dispose. I just make it iDisposable and I override dispose. And inside it, I manually close the connection. So that is the trick here. You have to do this manually. And the other thing is that you have to replace all the direct data context, your data context, with this your data context 2. Because if it's using your data context, it is going to fire the buggy dispose method and it won't close the connection. So you have to use this your data context 2 to close the connection properly. So that's a lesson learned. You can apply you need to apply this only when you have done this hack of setting transaction level and you are manually opening connection on the data context. If you're not doing that, then there's no need for this hack. So these are all the .NET tricks I had. So hopefully you will be able to implement them and save yourself from a lot of grief. Now there are a couple of highly generic techniques. They are not for ASP.NET. Even if you're developing on a non-Microsoft stack, you will still get to enjoy these benefits. So this is content delivery network. So we usually implement some optimization techniques on our websites, like compression of JavaScript or compression of CSS, combining files here and there. They come at quite some cost. You have to be very strict about it. You have to maintain some discipline while introducing new JavaScript file or changing a JavaScript file, or you have to set up compression on your server. So it requires some development testing effort on your side. But what we could easily do is, at a very low cost, is use a content delivery network. So content delivery networks are external services. So they have servers that are optimized to host static content, and you could host all your static content on a content delivery network. So what happens is that when customers visit your website, instead of the static content getting downloaded from your web server, they will come from your content delivery network cache servers. And they usually have cache servers almost in all major cities. So which means that when a user is visiting your website, they are not hitting your web server all the way to your data center. they might get a content delivery network cache server on their city, so which is very close to them and gets a very high speed response from them. So this way you can not only offload all the static content from your web server and save threads on your web server and make better use of those processing power for dynamic requests, you are actually serving the static content faster than what you could serve from your own web server, since they are coming from a server that is near to the user, so that's lower latency. And let me show you a practical example how bad latency is really. So one example is when you hit www.pageface.com from Washington DC, you get a 0.7 second latency because our server is hosted in San Francisco. But when you hit it from Australia, you get a 2.2 second latency. And the reason is that what happens, let's think about what happens from Australia. So when someone from Australia hits our website, from the user's computer, it's going to his broadband router. From broadband router, it's going to his ISP router. And then from ISP router, it's traveling through several routers and going to the internet backbone. And then it is going from Australia to Singapore, then Singapore to somewhere in Middle East, then somewhere in Middle East to somewhere in Europe. And all of these jumps, there are several hops, and eventually going to Washington, D.C., and then through US, it's eventually reaching San Francisco. So that is happening for each and every request. Every packet is doing around the world in 800 milliseconds or so. So every single packet has to do this long worldwide travel from user's computer to your server and all the way back. And that's what's called latency. It's a total waste. There's absolutely nothing being transmitted on the wire. It's just the time it takes for a packet to go to your web server and then come back. So CDN saves this significantly. So let me show you how a CDN saves. So let's think of a user. So user starts browsing his router, connecting to ISP router, and then another router is going through the internet backbone all the way to the data center. Then it hits the data center firewall, and then the firewall connects to your web server, and then eventually the request comes back all the way through your home user. So when you have CDN, this is what happens. So CDN will do some trick. So you do various tricks to divert requests to a CDN. So what happens is that the CDNs are usually very close to the users. So they might be in the same city or maybe in the same country. So the request will jump through much less routers or hops and then reach the CDN server, and the request will be served directly from CDN server. So what you can do is that we talked about putting all your static content on a different subdomain. So you say that you host a static.yoursite.com on a CDN, and then all the requests going to the static.yoursite.com will be served much faster. So CDNs will automatically deploy your static content throughout the world on all their cache nodes, so that anywhere from the world they will get much better performance. So there are two types of CDN. There's a static CDN. So when you register with them, they give you some certain subdomain on their domain. So for example, Cachefly is one of the CDN provider I have used before. So they will give you some domain, yoursite.cachefly.net, and they'll give you FTP access, so you can upload all your static content there. And then on your web application, you put this yoursite.cachefly.net before all the static files, before all CSS, JavaScript, and images. And then all the content gets downloaded from their cache server, and you get a much better performance throughout the world. Then there is the dynamic CDN. So what they do is that you don't really have to get a different subdomain. So what they do is they will intercept requests going to your website, www.yoursite.com, and then they will dynamically serve the request either from their cache servers or from your web server. And I found them really cheap. It's like 2 cents per gigabyte, about 3 years back statistics. So it's a really cheap and easy way to get a massive performance improvement on your website. The response is really visibly faster. The page load performance increases significantly. Switching between pages increases significantly as well. And the reason is that those servers are specifically tuned to serve static content. They are on a faster network. Their latency is lower. Their compression rate is better. So all possible ways they are better than anything you can come up with. So let's see how dynamic CDN works. So let's say we are thinking about the same scenario here, And another scenario I'd like to highlight here is that let's say that there's some one router there on the network which is hit by many users. So all the requests that are going through that particular router, the black router on this picture, they're suffering from congestion. That's the problem of traffic's going through the public internet, the regular internet backbone that you and I get to use. So they're highly congested by all possible traffic out there by the regular internet consumer users. So you suffer from this kind of network congestion. So if you're using a dynamic CDN, what will happen is that you are hitting the same domain, www.yoursite.com, but they have some dark algorithm. I'm using the physics dark term, which is a smart way to say I don't know anything, how it works. So they do is that they divert. They have some dark algorithm on the backbone itself that diverts the request to a different channel. So you don't go through, your requests don't go through the traditional congested internet backbone. It goes through a much optimized network, much optimized, faster path. And they get served from their static cache server. And if the static cache server doesn't have the file cached yet, it will hit your website, get the content, and then it will cache it, and subsequent request will be served from their cache server. Another thing they can do is that you might think that, well, all the requests are going through the cache server first. So isn't it introducing another latency here, that another server is sitting there intercepting each and every request, even if they're regular dynamic ASPX requests that I don't want the cache server to intercept. So they have come up with even better thing, that they can route dynamic request through the router. So it won't even go through the cache server to your web server. It will just automatically divert to your web servers. So that also eliminates another server sitting there intercepting each and every traffic. So that gives even sometimes this gives even better performance for all your dynamic requests as well. Even the requests that are getting served from your web server, because they are traveling through a optimized network, they get faster response here, even for dynamic requests. So that's how the CDN used. And finally, this is the last slide. So I will share a couple of disaster stories we have gone through and somehow survived. So sometimes we have faulty hard drives supplied by supplier, and we seem to get some data corruption. And this is very hard to detect. So you don't suspect that you are getting some exception in event log, and it is due to some hard drive corruption. So you will investigate all your code. You will try hundreds of ways to identify why is this certain event log exception is getting generated. You will tune your database. You will debug your database. You will debug your network. Hard disk is the last thing you will ever touch. And once you have exhausted every single thing out there, every single device and code out there, you would start suspecting something must be wrong with your operating system or your disk. And then you will probably use some hard drive diagnostic tool and find that your hard drive or data or controller is malfunctioning. So to prevent this, what we do is that whenever we get a new server ordered, we do a stress test on the hardware. So we run a tool called HDTACH, HDTACH. So that does a stress test on the hard disk, and you do it for 10 hours and make sure that your hard drives have no problem in it. The same kind of problem happens with controller malfunction. So you might think that you have a very nice RAID controller and you have mirror one, so two disks contains the same data. So even if one disk dies, the other disk will be fine. You'll be able to recover. But if your controller is malfunctioning, it is writing corrupt data to all the disks. So when controller goes wrong, you are dead. Your backup is completely gone. Although even if you have 10 disks there being under RAID 10, and the RAID controller gets corrupted and it's writing corrupted data to all the 10 disks, there's nothing really you can do. So the same thing you can do. So point number 1, 2, 3, they can all be mitigated by doing a stress test. So same HDTACH tool or some other tool that you can run for 24 hours maybe, and then do a stress test on the controller and the hard disk, and you test for overheating, you test for gradual slowdown, and of course any disk level or control level problem. Then we suffered from some CPU overheat problems. So sometimes our server CPU burned out and we had to replace the whole motherboard. And that sometimes happened for even new servers ordered. So what we usually do is that whenever we get a new server ordered, we not only do a stress test on the hard disk, we also do a stress test on CPU. So there are some tools available that can put every single core on your server to 100% utilization, and you run it for 12 hours at a stretch or so, and then you can see whether you have a CPU overheat problem or not. The most common reason is that the fan is faulty. So sometimes we get fans that are faulty, that don't rotate at the speed they should be, or sometimes they stop working under heat and the CPU burns out. So you should do this kind of test, mostly to test the fan, because if the fan works fine, even if at 100% utilization, your servers will be more or less fine as long as they are properly cooled. Then we had a problem. Firewall went down, and then it was a celebration for the hackers and all the malwares out there on the internet looking for a unprotected web server. So our firewall went down, and within hours we were seeing bizarre errors on our event logs and exceptions, web process crashing down, and some weird alert messages when we logged into our servers. We had our web servers compromised. So what do you do? I mean, the firewall is supposed to be the one that should be always alive and running and protecting you from malicious requests. And you don't really want to put firewall behind firewall. So then it is unnecessary latency that will introduce two firewalls intercepting your traffic. And you probably don't want to turn on both Windows firewall, the software firewall, as well as put a nice Cisco firewall out there on the internet. Well, so since this is very rare, I mean, we don't go through this kind of drastic measure that we put two firewalls, one behind another, so that if one goes down, the other can take over. We just live with one firewall. And we have enough redundant web servers and enough backups to go back online. So this happened only once in probably 14 years of my career. So maybe you don't need to do it, but if you're unlucky, I have heard that this happened to several of my colleagues. So if you are one of those unlucky souls, then you might want to take some preventive measures, especially for banks. I mean, they don't care about performance to users. They put 10 firewalls before the web server. So if you're building a very secure application, then you might want to do that. So don't trust the single firewall that you have on your public internet to be always up and running. You always have a standby server, of course, in case the main firewall goes down, you have a backup. And you might want to put two-level firewall there. Or you might want to put one firewall before your web server and then another firewall before your secure services that are there behind the scene in the secure network. Then another common problem that was happening quite frequently in the early days of Microsoft patching. So our remote desktop stopped working after some Windows update happened, and there were no way we could get into our servers. So we had to drive to our data center and then manually connect some laptop, some keyboard and mouse, and then connect to our database servers and monitor, and then do a reboot and uninstall the recent Windows update before we were able to remote desktop into it. And now there are some nice tools there. There's something called KVM switch that you can connect to your servers physically, and they connect to your network connection. And so what happens is that you can, even if your remote desktop is down, you can connect to a specific IP that the KVM switch is listening. And once you connect to that IP via regular straightforward Windows remote desktop client, it will show you the Windows desktop as if you are physically there and sitting. It will show you the console. So that is one of your backup measures. In case remote desktop fails, you can connect to the KVM switches. Then remote desktop max connection exceeded. I'm sure everyone suffers from the, you cannot really log into anyone. So there's just one trick. If you go to console and you write, if you go to run, Windows run, and write mstsc, which is the remote desktop client, and then /console, it will connect you to the console mode. So even if you're getting max connection exceeded, you can always connect to the console mode using this command line parameter mstsc space /console. And then you will be able to log in as administrator and kick the other users out who have left some orphan session on. And then another problem we had was the database got corrupted while we are moving the production database. So we were switching from one server to another, and while we were copying the gigantic 300 gigabyte production database, it was getting corrupted. We did several attempts within a very short window that we had to go live because we are doing a maintenance work. So we tried twice, and both of the time the database got corrupted. So the one way to, and the way you know this is that after you have copied the whole file, you have done a SQL Server restore for half an hour, At around 95% or 97%, SQL Server will tell you is that the data is corrupted. So you waste hours doing this exercise. So the best thing is that never move a database backup or a MDF, LDF files directly, copy them over the network. Always use some compression to compress them and move them. So what the compression does is that when you decompress the file, they do some CRC check and they can tell you whether the file has been corrupted or not. So you get to know when you are extracting the file, so you can do another copy right away. And you don't have to wait for SQL Server to restore the gigantic file only to know that the file is corrupted. Then the next thing is, well, there's really nothing you can do if that happens. God bless you. So one of our developer thought that he was connected to the SQL Management Studio on his local PC, but he was actually connected to the production database, and then he hit delete on a production database. And developers never read any message box that pops up. If there is a OK button, automatical instinct is to click that OK button without ever reading the message. So he did that, and our production database was down. So one way you could do prevent this is implement some security policy so that developers get only a read-only access to your SQL Server. But if you're in a small startup, you don't really want to lose the productivity. So you might want to give a developer some write access to the production servers, because we frequently do some cleanup job on our production server. So you don't want to lose this flexibility. In that case, having a standby log shift database, which is always a best practice, that you always have a primary database and that is log shift and kept one standby on a standby database. So whenever somebody blows up the primary database, you could immediately fail over to the secondary database and go online and then fix the problem later on. And then another very interesting incident we had was that we asked our support crew to format a defective server, which was the www.100.210, some weird numbered server you usually get from your hosting providers. And they formatted www.100.210. Just one digit was different. And they formatted the real production server. And our website was down, we were down. So to prevent this kind of problem, one best practice we do is that we do not use the default names that the number sequence, which are totally unreadable on our server names. We immediately change our computer name to something meaningful. So sometimes like we do web 1, web 2, web 3 as the computer names for our web servers, and then primary DB1, secondary DB2, so some very meaningful names, so that whenever you are connecting or doing anything on the server, you really know where you are connecting to. Especially if you have multiple remote desktop running, you sometimes keep track of, you lose track of which server you are connecting to. So if you have a very meaningful name, it saves a lot of human error. And Windows gets corrupted very frequently. I'm sure that's a common problem in the Microsoft world. Fortunately, since Windows 2008 came in, this no longer happens. But before that, it was a real nightmare. Every month, we used to get some Windows getting corrupted, and we had to reinstall it. And one of the main reasons was that, of course, we are a small startup, and our developers were playing around on the Windows server. They were sometimes installing Visual Studio on production server and sometimes doing code changes there. So that's not a recommended thing. You never ever install Visual Studio on a production server. And you never ever install Microsoft Office on a production server. So if you do that, then surely your web servers or your production servers will gradually get corrupted. And it will install a lot more Windows update than it usually will do. So that causes some other problems. Sometimes these Windows updates are not tested in every possible scenario, so you get to be a victim of some untested scenario and your server goes down. Then the next thing happened is that our DNS went down, and when your DNS went down, you really have nothing to do besides spraying, and you never ever should buy domain from GoDaddy. That's the last thing you should do, to buy a domain from GoDaddy for your business websites. For personal website maybe, but never from GoDaddy. And the main reason is that the GoDaddy DNS servers are really slow. I mean, they are cheap for some reason, of course. They're extremely slow. We saw that from Australia, a regular DNS result took 0.7 to 8 seconds on our web server when we were on GoDaddy. So you definitely need to get a domain from some commercial domain provider who have enough backup for you. And their support never responds, so don't bother calling them. And the last thing, I mean, it's a 13th disaster there's a significance for the 13 number. I mean, you have to be really lucky, really unlucky, 1 in a billion to go through this problem. So interestingly, we had the hosting provider we are using, they were using a certain internet backbone. And that backbone went down, and you know what happens when a backbone goes down. I mean, every single hosting provider using that backbone, almost a part of the world on internet goes down. And we were very unlucky to be a victim of that incident. It was around 2007, I believe, when a certain backbone provider went down, and all the hosting providers who had only that backbone, they didn't have any backup backbone, although they advertise on their website. You see them saying that they have redundant backbones and all these things. They can fail over within 300 milliseconds or so, something like that. But practically, I mean, that doesn't really work. They never try this kind of thing because it's very, very expensive to test this kind of backbone switchover. And you have to inform every single of your customer that we are going to do a backbone switchover test now to see if this really works or not. And your thousands of customers will then complain there's no way we can afford a 10-minute downtime or so. So when your backbone goes down, you're pretty sure that there's nothing you can do. It has never been tested, and you are a victim of that. And when the backbone goes down, what happened was that there was a certain backbone that goes to Washington, D.C. That was down. So our hosting provider was one of that. And there was no traffic that was getting served from Europe and major part of the Asia. So we lost more than half of the world worth of our users not being able to visit them. Only those who were in North America and South America were getting our website. So you can go to this URL, tinyurl.com/Omar13. You will see a detailed explanation of each of the disaster and how to recover from them. Hopefully that will save you a lot of hours and your dignity, and hopefully VCs won't withdraw their money from your startup. So thank you very much. That's all I have to share for today.
Well, thank you, Omar. That was a great presentation. We've still got 30 minutes left if you want to do some questions and answers or have a bit talk to some of the members that are here, you know.
Sure, no problem.
I mean, it's entirely up to you.
Has
anybody got any questions? We've got 101 people in the audience there, so I'm sure somebody must have some questions. If you have any questions for Omar, then please feel free to enter them into the questions and answers panel on your live meeting console.
The way you do it is that there is a Q&A icon on top, and you go there and press the ask button. And the
oh, here we go. There we go. We've got some questions coming through for you, Omar.
Right. Is there a way to open a voice for everyone, or that will be chaotic?
We can, kind of, but we'd rather not,
Okay.
because it gets very, very, very difficult to manage it.
Okay.
You know, we'd rather just take them in the Q&A tab.
Sure. So I will answer the first question. It's from Jeff Young. Which domain name providers do you recommend? I'm trying to remember. I think it was Ultra DNS where we switched to. So it was about 5 years back. But you can do some Google search, commercial DNS provider. If it costs more than $50 per year, you can more or less be satisfied that it's a reliable service.
Can I also add to that one?
Yeah.
I don't know if anybody knows this, but Google actually provide an ultra-fast cloud DNS service. I believe the address is 8.8.8.8. I'd have to double check that just to make sure. But in places like myself, for example, I run my own DNS servers on my internal network, and my DNS server upstreams directly up to Google's. Now, because it's cloud driven and it's in all of Google's cloud data centers, it's pretty much instant replication around the world, and the speed return I get using that DNS is absolutely fantastic. And there's nothing stopping you, even just on normal PC, substituting your own normal DNS address for Google's DNS address rather than your own ISP's address in your network adapter properties.
Okay, excellent. Right, I will pick the next question is from Patrick. I have no way how to pronounce your last name, so sorry about that. The msdsc/v:server name/console doesn't work on all my server. I'm trying to remember, I had the same problem, and I think it was some kind of a remote desktop setting where you have to turn on that allow console login. Unless that is turned on, it doesn't work. So you will have to go to the remote desktop manager or remote connection manager. There's something under the administrative tools on Windows servers where you can go and turn this on. Okay, the next question is from Brian. What was the decision for starting of PageFlex? That's an ancient history. Well, I vaguely remember the one of my colleague who is actually a serial entrepreneur and angel investor himself, Christoph Jans. He's from Germany. So he once emailed me that is there something we can do for Web 2? It sounds like the Web 2 craze is starting, and I would be interested to invest in something doing in the Web 2 world. So I was thinking that, okay, what's the killer web application we can make that will be super Web 2 and Ajax and will use the all possible web technologies out there, and I will get to test all of the technologies myself and will become an expert, and maybe we'll be able to make a killer web application. So we brainstormed on a couple of ideas, and we realized that if you make a personalizable start page, the idea was that we wanted to build a kind of a dashboard that aggregates a lot of information. So Christoph was an avid reader of RSS feeds, and he was also looking for a solution to read a lot of information in a single page. And I was also doing the same thing, that I was following a lot of forums, so developer forums, and I wanted to have a nice unified view of feeds coming from a lot of forums. So we both agreed on an idea that we'll go for a information aggregator type idea. And we decided that the best thing we can do in the Web 2.0 world is that allow users to build their own page, so they can drag and drop widgets on their page. They can configure those widgets and create a very nice personalizable start page experience. And we really wanted to hit the start page of users' browser. We wanted that every morning users will wake up and PageFlex would be their start page. They will start their day with it. And that's the name that came up. So every morning you wake up and you have cornflakes for your breakfast. We're hoping that with cornflakes you will have some PageFlex. So that's where the name came out. So that was the inspiration. And then I will take the next question from Rory. Does the ASP.NET membership provider use subdomain cookies? Referring to your suggestion to use a subdomain for hosting static content, is it better to use a different URL for static content? Right, okay. Yes, the cookie that gets issued by the ASP.NET membership provider is for the subdomain. So it will be issued on www.foo.com if that's what your subdomain, the application is hosted on. It won't be on the foo.com domain. It won't be a domain-wide cookie. It will be a subdomain-wide cookie. And that's why the static subdomain works. And you have also suggested that how do you disable /console on MSDSC. So there is some link there. I don't think others can view it. Do they? No. Okay, the next question is from Laura. What do you suggest database failures? Mirrors? I always go for the standard SQL Server log shipping. That's a common practice everywhere. We always go for that, the log shipping one. And I know that the SQL Server 2008 has the DB mirroring, but the problem of that is that the DB mirroring, you can only configure it in a sync mode, which means that it will, when a transaction gets committed on the primary database, the transaction will get committed on the secondary database in a synchronous manner. And after that, the query execution will complete. And we always thought that that's a bit risky. I mean, that's what is there in the SQL Server Standard Edition. But if you go to SQL Server Enterprise Edition, you can configure some async mirror. So the insert or update or delete on the primary database will happen immediately, and the query will return, and then asynchronously the secondary mirror server will get updated. But that asynchronous feature is available only on SQL Server 2008 Enterprise Edition, which costs a fortune. and we thought that that's not a cost-effective solution. So let's just get to SQL Server 2005 or 2008 standard edition and do SQL Server transaction lock shipping. So lock shipping has been available since SQL Server 2000, I believe even earlier than that. So it's a pretty well-tested technology. I'm not saying the mirroring is bad. I mean, if you don't bother about that synchronous execution delay, that every single insert, update, delete will now have to be performed on 2 databases before they complete. If you can afford that, fine, you can do that. You can use the SQL Server mirroring on SQL Server Standard Edition. Okay, I need to mark the answers as answered, isn't it? Otherwise, the same person cannot submit another answer. Okay, I will do that.
Yeah, just tick them, Omar. The guys that are working behind the scenes will remove them from the list as you tick them.
Perfect. Okay. Then Scott Sumter was asking that what kind of performance profiler do you recommend? I mostly use the Windows Standard Profiler to observe on the server what's going wrong. So Windows Profiler is pretty sophisticated, and I believe I have made some blog posts that what are the common performance counters you should always configure and observe on your production servers. You might want to find that from my blog. It's omaralzabir.com. There is a tag production, I believe. If you filter on that tag, then you will find the blog post there. So you should never use any kind of profiler that attaches on a process or does any kind of interception on a production server. You have to rely on the default Windows profiler. So on the Windows 2008, I believe it's called Reliability Performance Monitor. I believe previously it was known as just Performance on the Administrative Tools menu. So we use that and we configure the ASP.NET counters on a database server. We configure some SQL Server database counters and we monitor those. And you can also set up some alert that if a certain counter has exceeded a certain value, then an event log entry will be created. And then you would know that something had gone wrong before. So you can then go and investigate that. Okay, taking the next question from Chris. Do you think moving to cloud hosting like Azure, you will avoid the hardware problems you mentioned earlier? That's an interesting question. Hopefully you do. I mean, I assume Microsoft gives you some SLA or some guarantee that the underlying server is so extremely mirrored and so redundant that any kind of outage out there, like a disk outage or a complete server outage, wouldn't cause any problem. So I don't have extended experience on Azure, so sorry about that. I haven't deployed any application on Azure and scaled it to millions of users, so no personal experience. Sorry about that. But I believe Microsoft does give you some SLA that they will take care of it. And if I remember the Azure architecture correctly, it's extremely virtualized. So even if the whole physical server goes down, they have redundant servers running the same virtual image of your application, and the disks are all external SAN. So very little chance of having any problem on the disk level. And networks, of course, they have extreme redundancy there as well. So you won't have a single firewall going down kind of issue there. You might get hit by the internet backbone going down, but I believe Microsoft Data Center has a lot of redundant backbones because they were never affected by any internet backbone going down problem. Never heard about that. So I think Azure would be pretty foolproof. You should go with that.
Omar, I'll just add to that if you don't mind.
Sure.
On Azure, actually, your content and your data and your application is stored in 3 separate locations at any given time. Microsoft offers a 99.9999% uptime.
Oh, wow. Okay.
And yes, you are correct. The containers actually do that. All the servers come in data centers actually is completely redundant to the extent where servers can physically die inside the containers, and they don't even bother replacing them straight away because there's so much.
Sure.
So many resources available to them still. Obviously, a worldwide or a power outage or backbone from almost every provider you have. If net falls down, there's not much you can really do.
I see. Okay, great to know. I'm pretty sure the Microsoft definitely they have their own data center to worry about, and they have their own sites and applications running on Azure, so they must be very resilient. Okay, the next question is from Asit, my friend Asit. Okay, so was the new version of VS a CDN handled by Microsoft? If yes, do we need a third-party CDN? Well, the CDN that Microsoft offers is only for some AJAX scripts. I believe the jQuery frameworks and all those commonly used JavaScripts, you can directly get them served from Microsoft CDN. And Google also has the same CDN. But that's only the common frameworks. If your own CSS or your own JavaScript or your own images, if you want to put them on CDN, I don't think Microsoft, neither Google or any one of those large companies offer that. So you have to go to some third-party CDN to get them, and they're pretty cheap. You get about 100 gigabyte storage space and 1 terabyte data transfer per month at about $20 per month, so which is pretty cheap. Yes, you need to go to third-party CDN for your own content. Okay, we'll take the next question from Christopher Halam. Regarding the DOS attacks you spoke of earlier, if you detect the preset threshold has been met by a particular IP, do you simply issue an end to the response, or would you potentially add the IP to a list of unauthorized IPs via IIS? Can that even be done programmatically? I haven't seen that being done programmatically. But yes, you could do a log entry, of course. Depends on whether you want them to permanently block or not. Yeah, but you could log them in a log file, and then end of the day probably go to IIS console and then add them manually. But I wouldn't probably bother about that. Well, actually, I remember an incident. It happened even in BT that we had somewhere from Africa, we are getting this kind of denial of service attack that someone was sending a lot of traffic to our website from a certain IP, and they were causing some high CPU. And yes, we detected them from our log. So we were actually logging this kind of IP violation, and then we had to block that IP permanently from our firewall. We usually go to firewall and do it. It's easier to do it on a firewall than IIS. So you go to log into Firewall console and just run a single line command, and the IP gets blocked. So it doesn't even hit your IIS.
For the record, Omar, IIS 7 does have .NET bindings now. It has a much richer programming model than anything previous to it did. And there's lots of things. You can actually, a lot of the stuff that you do in the console for IIS 7, you can do directly through .NET code with the .NET runtimes, and what you can't do through a direct .NET code binding, you can do by hooking into the PowerShell .NET libraries and automating it with PowerShell.
Excellent, yeah. Okay, I'll take the next question from VB. It's Visual Basic, isn't it? Okay, if a website slows down terribly and randomly, which otherwise works normally most of the times, is there a checklist of things to do to identify the problem quickly? Yes, there is. So I actually started creating a decision tree somewhere. So I will find that link and post it on my blog, which kind of shows you a decision tree that is your website responding intermittently, you go through this path of the tree, or your website is completely down, you go through this path. If your website is completely down, does the event log have the app pull crash event recorded frequently, then go to this decision tree, the branch of the tree. So I created a nice flowchart kind of thing that how you can do a process of elimination and do some divide and conquer method to narrow down where the problem is. So I will make a post on that. I think it will be a very useful thing to do. Okay, the next question is from Mikkel Holk Madsen. Apology if I haven't pronounced it right. Have you thought about switching to Azure hosting instead of traditional hosting centers, as they claim that scaling should be much easier? Yes, I have actually. But the problem with Azure is that you have to do a lot of re-engineering of your code to really leverage the redundant features that Azure offers. So I haven't had any opportunity to build an application from scratch since Azure came online. So I haven't been able to try that out. Also, the problem is that most of the companies, most of the large enterprise companies, they have their own data center, so they don't want to go and host their applications outside. But if I were in a startup, I'm sure the Azure would be my first preference now to try out. So yes, the scaling should be definitely much easier, and once you leverage their features, like you build web roles and you build, you use the Azure entities and Azure Cache. If you code your application using those Azure native features, then certainly there should be highly scalable and easy to maintain and scale up and down on demand. You wouldn't go a regular traditional route. So if you have the option, go for it. I haven't read any bad press about Azure, so I guess they're pretty good. But I have no personal experience, so I cannot speak from my own experience. Okay, the next one is from Pedro Jimenez. I believe, again, I apologize for mispronouncing. So would it be better to host static content on Apache in a separate server VM? Yes, I have certainly seen many people do that. They think that IIS is a really big beast and it causes unnecessary CPU. So you get some very stripped down Apache servers nowadays that are specifically tuned to deliver static content, and they have almost nothing there. There's no module there. There's extremely slim Apache installation, which does one and only one job: serve some static file. And in that case, you will probably get some better performance. But I believe what IS7 has done, and I have seen some performance comparison from Microsoft, so don't believe them entirely, that they have proved that from a load test that IS7, when it uses the system level cache, which is the http.sys, it's almost like a driver level cache in Windows, you actually get much better throughput for static files than if you install Apache on a Windows. So you might want to use the IS7 caching features and then serve static content from there. But if you have to have a custom trimmed down, very slim Linux installation and those highly tuned customized Apache installations for serving static content only, maybe that gives a better performance. I don't know about any load test done on this comparison, but I know that on Windows, if you install Apache, and if on Windows, if you use IS7, the HTTP runtime cache, IS7 will always outperform Apache because the caching happens almost at the Windows core level. So the request, the static cache request gets directly served from some http.sys driver directly. So it doesn't even go through the expensive ASP.NET runtime. So you can configure IIS to serve content directly from this kind of cache. Then IS7 outperforms everything. Okay, I'll take the next question. Chris Amelins. And so for AJAX calls, supposing you can't send them to the static subdomain, how do you avoid cookies and related overhead? Well, on an AJAX call, would you want to send requests without the cookies? Because if you're making a web service call and you have a membership cookie issued, that cookie tells you who the user is. So from the AJAX call, you definitely want to get the cookie, identify the user, and then do the job. Unless if you're doing very simple things like a autocomplete, which doesn't require any authenticated request, then yes, you could easily afford them. But usually, I assume that your applications you will want to do some authentication and authorization on the AJAX calls itself. Otherwise, your web services will be exposed on the internet without authentication and authorization, and anyone will be able to call them with a malicious payload and get someone else's data. So I wouldn't recommend putting the secure authenticated AJAX services outside the regular www domain and hit them without the authentication cookie. But yes, of course, for regular things like autocomplete, which doesn't require any authentication, you could easily put them on a static domain. In that case, it won't work because browsers have this cross-domain policy. I don't know if that limit, I forgot if that limit is there on subdomain, but in that case, you can probably use the JSON-P model using some script tag to hit a different subdomain or a different domain AJAX call and then get the content pushed back and call some JavaScript function. So there is a model JSON-P which you can use to call AJAX on a different domain. Okay, the next one is from Jeff Young. Windows Azure offers a CDN, pretty easy to configure on your website or from blob storage. Any comment on it compared to some other CDN options you mentioned? So I haven't used Windows Azure at all at a production scale, so and CDN I haven't used that either. So I'm sorry about that, I cannot comment on that. I think that was the last question.
Yep, it looks like it. Well, we've put it 25 minutes, so I think we did pretty well there. Thank you very much. That was a very informative talk. I've got to admit, I learned a thing or two as well.
Okay, thank you everyone for joining this session. It's my honor. Thank you.
Not a problem. Thank you, Omar.